All right, everybody. Good morning. How are you? I hope you're rocking and rolling, moving and grooving. So, today we take a little bit of a turn on our journey of understanding mathematics and we begin to explore some geometry. Now, you got to remember that this course is not a specific course in algebra, it's not a specific course in geometry. It's a course where we try to get you to think conceptually about math and then we begin to apply it to a bunch of real life circumstances. A lot of those are involved in geometry. So today we get started on studying geometry. We'll continue that for the next few lessons and it'll weave its way through similar figures and trigonometry. And then after that, we're probably looking at some study of statistics and so on. So without any further ado, week 9, lesson number 1, let's take a look at where we stand. What do we have to do today? Our agenda. We have our homework answers to go over. We have a do it to do. We have some review work to get going on, always spiraling our material. A little quick geometry review of vertical angles and supplementary angles. Very, very fundamental stuff you've probably been doing since 8th or 9th grade. And then we're going to talk a lot about parallel lines cut by a transversal because that leads us into some understandings of triangles that we're going to get to next session. Okay, here is your first homework, first set of homework answers. Take a look at it. If you have any questions, as always, please reach out and understand. But first, try to understand the work on the page in front of you or speak to a friend and then check me out. And don't forget your office hours are available Mondays, 7 to 9. Okay, here's the second part of the homework. All right. So today's do it. Simplify two algebraic expressions. The first one is just to reduce the rational expression, and the second one we got to do some multiplication. Go ahead, you know the drill. Stop and start. Okay, so factor and cancel, factor and cancel. All that you do is you factor and cancel. So I factored g squared plus 16g plus 63. What two numbers multiply out to 63, add up to 16? Bam! That's 9 and 7. I don't know why I have a 6 and a 7 there. So let me correct that right now. Probably left over from the last time I did this. Okay, there's the G plus 9s. And I actually had these little lines in place, so as far as I was concerned, I was going to cancel here anyway. And that leaves us with 1 over G plus 7. The thing to not forget is that it's 1 over. Remember, G over 9 plus over G over 9 means or equals 1. And 1 times anything is itself, so that's just 1 over G plus 7. Okay, the next one, factor and cancel, factor and cancel. All that we do is factor and cancel. So I factor 5 times q plus 5. I get 5 times q plus 1. By the way, that'll be the same thing on the bottom right. Q plus 8 here. And factoring q squared plus 19q plus 88, I get q plus 11q plus 8. Start canceling. I get the q plus 8s and the q plus 1s. I also get the 5s, and that leaves me with 1 over q plus 11. The thing I'm looking to emphasize with today's do it is that you remember if there's nothing left in either the numerator or denominator after you cancel, there's really always a 1 there. We just don't bother writing it. Okay, let's try some review questions. Give this one a shot. Okay, so this kind of question can frustrate students very much. If one side of a square is increased by 10 centimeters and the other side is increased by 5 centimeters, a rectangle is formed with an area that measures 3 times the area of the square. Find the length inside of a square. So what frustrates a lot of students here is they go directly to drawing the rectangle. Sorry about the dogs barking there. Excuse me. So what do we do? given that it's a square being increased by 10 and also by 5, each of the sides. And students tend to go right for the rectangle because it starts talking about that. But start with the square and then increase them. Okay, there's new dimensions. The width becomes x plus 5, the length becomes x plus 10. So what happens is the new one, x plus 10 times x plus 5 is equal to 3x squared. 3 times the original one. So the original square is x squared, multiply it by 3, and the width is x plus 5, the length is x plus 10. So the new length times the new width is 3 times the old one. Double distributing, I get x squared plus 5x plus 10x plus 50 equals 3x squared. Combine like terms, get all my... Now, there's a tendency here on students to want to subtract the 3x squared. Don't do that. Subtract the x squared minus the 15x minus the 50. Factoring, this is a lead coefficient other than 1, so I multiply the 2 by the last term, which is negative 100. Factor that. I get x minus 20 times x plus 5. But since I multiplied by 2, I have to come back in and divide by 2, which I just did. And that gives me, oh, here's the, I meant to have this shown earlier. Here is the new length and the new width in the diagram in case you don't realize it, right? Here's the new rectangle, x plus 5, x plus 10. Getting back to solving the problem, 20 over 2, reduces to 10, so I get x minus 10. And the next one is 2x plus 5. Maybe it's the guy on the left, maybe it's the guy on the right. I get x equals 10, x equals negative 2.5. Can't have a negative length, get rid of that. So 10 is going to be the length of the original square. Okay? All right. Good problem to do here. Real nice problem. Has some nice factoring in it. Has the changing of the shape so that you understand where it goes. If you struggled with that, maybe go back to try and do it again, but this time start by drawing the diagram the way I did, the original square and then increasing by 10 and increasing by 5. Okay, solve by completing the square. Go ahead. Okay. So normally speaking with a quadratic, we always try to get everything on one side. But when it comes to solving by completing the square, we don't want to do that. So our first step is to subtract the 8, and we get x squared plus 18x equals negative 8. Do you remember the phrase, 3 words, that you have to remember when you solve by completing the square? The way to do that is half and square. So half of what? Always half of whatever's in front of the x, the coefficient of the x. That's 18. Half of it is 9. However, what we have to remember is x squared plus 18x does not equal x plus 9 squared. That's the half for the 9. The square part is plus 81. So there's really a plus 81 missing on the left at the first step. That's included in the second step when I write x plus 9 squared. So I have to add that 81 to the negative 8 because it's already included in the package x plus 9 squared. So negative 8 plus 81 is 73. I square root both sides. The square root, that shouldn't be over the equal sign. The square root of x plus 9 squared is just x plus 9. That's going to equal plus or minus the square root of 73. Subtracting the 9, and I get x equals negative 9 plus or minus the square root of 73. A very good technique for solving unfactorable, excuse my yawns, unfactorable quadratic equations. Half and square is the phrase to remember. Okay, so one day someone was sitting around with nothing better to do, as mathematicians are wont to do, and they start playing around and they start solving ax squared plus bx plus c equals 0 using completing the square, and they come up with this thing called the quadratic formula, so that if completing the square frustrates you, and it does not me, I like completing the square, you can always use this particular formula. And then, of course, on some questions, it will say use completing the square, and on other ones, it'll say use the quadratic formula. In the meanwhile, use the quadratic formula to solve the same exact question, x squared minus 4x equals 8. And remember, the key first step is to make sure that you get everything on one side when you use the quadratic formula. Leave it like this when you do the completing the square. Quadratic formula, get it all on one side so you can get the right value for C. Okay, time to stop and start. Go ahead. Okay, so I get the 8 all on one side, and I get now that A is 1, B is -4, C is -8. So what do? I plug them into the formula. So I get the negative of -4 plus or minus -4 squared. So important to write that in parentheses. If you do not, and you have a really good calculator, it will get it wrong every time, because -4 without parentheses squared means square the 4, then negate it. That's following the order of operations. To tell it you want to do -4 times -4, you have to put it in parentheses. That's what we're talking about right here. -4 squared in parentheses. Minus 4 times A, which is 1, times C, which is -8. All over 2 times 1. So the negative of -4 is 4, plus or minus. -4 squared is 16. If you didn't put parentheses, it would have said -16, and the whole problem would be wrong. And then plus 32 over 2. And then finally, 16 and 32 make 48. So it's 4 plus or minus the square root of 48 over 2. And technically speaking, okay, this would be 2 plus or minus 2 radical 3. But we didn't teach you how to simplify radicals, so we won't go that far. All right, we're leaving it 4 plus or minus the square root of 48 over 2 is good enough for now. Okay, excuse me, on. Next question. Uh-oh, Wheel of Death. This is to show you how a trained professional handles an emergency situation. Hopefully, this is not a big issue. What you just heard was my external hard drive going off in the background. Solve using the quadratic formula. 2x squared minus 3x equals 18. We know the first step is to subtract 18, get it all on one side with the quadratic formula. We want equals 0. There's A, B, and C. Solve it up. Go ahead. Okay, so what do we get? We get x equals the negative of -3 plus or minus -3 squared. Not berated, but we definitely emphasize the need for parentheses there. Minus 4 times 2 times -18, all over 2 times 2, because A is 2 this time. And I get 3 plus or minus the square root of 9 plus 144 over 4, which is 3 plus or minus the square root of 153 over 4. A lot of students really like the quadratic formula. They just find it very mechanical. They can grind through to the answer. And honestly, it doesn't require much thinking once you get started. Okay, perform the indicated operation. Express in simplest form. Subtract those two fractions. So this is the last day that we're really going to do a lot of emphasis on algebra in the review. What we ask ourselves here is, what does the fraction on the left need that the fraction on the right has? That would be an x plus 1. And what does the fraction on the right need that the fraction on the left has? That would be an x minus 1. So I distribute the 2x to the x plus 1. I get 2x squared plus 2x over my common denominator, plus distributing the 5x minus 5 over my common denominator. And the last step is to combine like terms in the numerator. And I get 2x squared plus 7x minus 5 over x plus 1, x minus 5. Now, there is a caveat at this point, a warning. You need to check and see if 2x squared plus 7x minus 5 is factorable. And then if it is, you factor it. And then you look for any more cancellations. I tried 2x squared plus 7x minus 5. Couldn't see a way to factor it. Okay, the next thing that we worked on was solutions of simultaneous equations. Give it a shot. Go ahead. Okay, so, oh, I can choose to get rid of either variable here. And if you're developing a little bit of an instinctive feel for this and the concept behind it, you'll say to yourself, well, the easiest thing for me to do is multiply the top equation by -5. That's because it would match up my y's, and then I don't need to multiply the bottom by anything. And to be honest with you, if I was doing it myself, that's how I would do it. But I still think a lot of people are saying, okay, look, if I just take the bottom coefficient, multiply it by the top by the bottom, and so on, then I know it's going to work. So I made it a point to do that. So instead of getting rid of the y's in one quick, easy step, I'm getting rid of the x's. Now, if you chose to get rid of the y's, you will get the same exact answer I do. And honestly, you're doing it a better way. But if you chose to get rid of the x's, it works too. So I want to get rid of the x's. I realize 6x is a multiple of 2 and 3. And what I also realize is if I just take, and this is why I like to do it this way, because it's like the previous problem, say to myself, look, what does the bottom denominator have the top one needs? It's a 3. Vice versa, what does the top have the bottom needs? It's a 2. I don't need to put a negative sign anywhere because it's already there. So distributing the 3, I get 6x minus 3y is 24. Distributing the 2, I get negative 6x minus 10y is 2. Adding up the equations, you'll notice that the 6 and the negative 6x add up to 0. So I get negative 13y equals 26. Dividing by negative 13, and I get y is negative 2. There is a tendency at this point for students to think that they are all done. No. You need to go back and get x, okay? You can use either equation. I'm going to use the top one. 2x minus y is equal to 8. 2x minus a negative 2 is plus 2, is 8. 2x is 6. X is 3. And there's my correct solution. X is 3, y is negative 2. If you chose to eliminate the y's first, the way I mentioned with the -5, then you would have just found the x answer first. And then you go back and get the y. But it works either way. All right, here's one to do again, but this is not elimination. This is substitution. Go ahead. Okay, so I know that a y has the same exact value as an x minus 1. So I rewrite the original equation, but this time I'm going to substitute for the y, x minus 1. So 2x I keep the negative, I keep the 3. I do not keep the y. I substitute for it. What can I trade the y in for? Well, I can trade the y in for whatever it exactly equals, which in this case is an x minus 1. And then, of course, equals -1. So I keep the 2x, I keep the negative 3, I keep the equals -1, but instead of the y right there, I just substitute what the y is equal to, what the blue underlines, which is an x minus 1. This looks like an equation from the first day of class. Distributing the -3, I get 2x minus 3x plus 3 equals -1. Combining my like terms here, same side, same operation. Negative x plus 3 is -1. Subtracting the 3, I get negative x is -4. Don't forget about that negative there. So that means x is positive 4, right? Dividing both sides by -1. Got to go back and get y. Y equals x minus 1. That's the great thing about the substitution technique, is going back and getting y is really easy. Substituting in the 4, y equals 4 minus 1, or better known as 3. Okay? So I do think that by now we've spiraled so much of this work, and I tend to think that you're very good at it. If not, put in a little extra time on your own, going back and checking out these problems. It's one of the great things about this course being an asynchronous or video course. You can always go back and check out the sections in the video again. Okay, now we go to a quadratic linear system. We did mention a while back that these will all be solved with or the tendency is to think that they will all be solved with substitution. So go ahead. Okay, so since y equals x squared minus 10x plus 14 and y also equals 7x minus 16, that means that x squared minus 10x plus 14 has to equal 7x minus 16. Quadratic equation, so let's get it all on one side. I subtract the 7x, add the 16, and I get x squared minus 17x plus 30 equals 0. Factor, what two numbers multiply out to 30, add up to negative 17. That would be negative 15 and negative 2. And maybe it's the guy on the left, maybe it's the guy on the right. Solving, x is 15, x is 2, and they both work. Okay, got to go back and get y. If x is 15 and x is 2, I substitute back into the easier equation, y equals 7x minus 16. This does work in both, but this is easier. Y is 89, y is negative 2. So I get 1589 and 2, negative 2. Okay? All right, now, review from times past. Now we're starting to get into the new work for today. We've spiraled and reviewed most of the work for the last couple of weeks so far in this lesson. This is a diagram. I call this the Great Big X. Okay? And this is a diagram of angles A and B. And angles A and B are what we call vertical angles. There are two possible relationships in this diagram. One is the relationship shared by A and B, where they're across from each other in this Great Big X diagram. When that happens, they're called vertical angles, and they're always equal. So the problem asks you to find the x, the measure of angle A, and the measure of angle B. With that little introduction I just gave you, give it a shot. Okay, so A and B, angles A and B are congruent. They're equal to each other. So 7x minus 11 has to equal 2x plus 34. Subtracting the 2x, adding the 11, and I get 5x is 45. Remember, this is not quadratic, so we don't get it all on one side. Dividing by 5, and I get x is equal to 9. Okay, I did the first part. What's the measure of angle A? I substitute the 9 in, and I get 7 times 9 minus 11 is 52. Let's show you that B equals the same thing. B is 2 times 9 plus 34. That's also 52. Always comforting when we check our work and see that it works well. Now, there's one other relationship in this diagram. The ones that are directly across from each other, be it A and B, or the ones without letters. The angles A and B are equal to each other. The ones without letters are equal to each other. But what if I take angle A and then this angle to the right of it, above B, that is not named here? Call it C if you want. What's the relationship between those two angles? Well, they add up to 180 degrees. They're what we call supplementary. Anytime two angles make a straight line and they're adjacent to each other, they add up to 180. How come? Well, I could draw a whole circle here, and the whole circle is 360 degrees. When they make a straight line, it's half of the 360, which is 180. So that's why two angles add up to 180 when they're next to each other and make a straight line. Oh, apparently I put this information in twice. Speaking of two angles next to each other, once again, a reminder, follow my cursor here. If I went from where I started to where I finished, I would be creating a circle. Okay? Circle has how many degrees? 360. If instead of going around all the way, I go halfway to here, then those two angles have to have half of 360 degrees. Half of 360 is 180. Try the first one. Go ahead. Okay, so 5n plus 10 plus 4n minus 1 is 180. Combining like terms, same side, same operation, both for the n's and the numbers. 9n plus 9 is 180. Subtracting 9, 9n is 171. Dividing, and I get n is 19. Okay, n works out to be 19. Now, you try the next one. Go Okay, so those two angles add up to 180 degrees again for the same reason as before. Same side, same operation. 2n plus 3n is 5n, plus 15 is 180. Subtracting 15, I get 5n is 165. Doing my division, and I get n is one of my favorite numbers, 33. Okay, so these two ideas of vertical angles being directly across from each other and two angles next to each other adding up to 180 degrees really sets the understanding for this diagram. Very famous diagram. I'm sure you did it when you were in school, public school or private school, wherever you went. Two parallel lines cut by a transversal. Now, the parallel lines are K and M, and that's denoted by this little arrow on the line. In case you never knew it, that indicates that the lines are parallel. The transversal is T. And there's a whole bunch of angles here labeled 1, 2, 3, 4, 5, 6, 7, and 8. So notice that 1 and 3 are diagonally across from each other, right? They're vertical angles. So angle 1 and 3 have to equal each other. Likewise, 2 and 4 are across from each other. Those are also vertical angles. So they have to equal each other. So the first set of relationships established here is that 1 equals 3, 2 equals 4. The next one is that together 1 and 2 make a straight line. See, half a circle. So 1 and 2 add up to 180. 2 and 3 add up to 180. 3 and 4 add up to 180, and so on. Basically, any two angles that are next to each other, they add up to 180 degrees. Now, what can you do next? You could say, well, wait a minute now. Since the lines are parallel, that means that the alternate interior angles, namely 4 and 6, we say alternate because alternate means to switch sides, right? So angle 4 is over here, angle 6 is over here. 4 and 6 are switching sides of the transversal, okay? And they're interior, meaning they're between the two parallel lines. So 4 and 6 are alternate interior angles, as are 5 and 3 or 3 and 5, okay? 1 and 7 are alternate exterior angles. Now, if I take the top set of angles and I drag it to the bottom set and I drop it, you've done drag and drop, right, on your computer? If I drop it, the 1 lands on top of 5, the 2 lands on top of 6, 3 on top of 7, 4 on top of 8, and we call that corresponding angles. Angle 1 and 5 correspond, 2 and 6 correspond, 3 and 7, 4 and 8, and so on. Basically, if we boil it all down to a nutshell here, and I have to get my dog and shut him up in a minute, what I have here is all of the acute angles, acute being less than 90, they are 2, 4, 6, and 8. They're all equal to each other. 1, 3, 5, and 7, all the obtuse angles are equal to each other. And any single acute and any single obtuse together add up to 180 degrees. That's the relationships we have. Okay, if the measure of angle 1 is 130, find the measures of the other angles. Don't necessarily do stop and start. Do the best you can. I'm going to silence my dog. Okay, I'm not going to kill him. Obviously, I love the dog, but I am going to silence him. I'll be back in just a moment. Okay, sorry about that. It is honestly a little unprofessional, but my wife was not home to let the dog out. He needed to go to the bathroom. And the other problem is that I don't know how to pause this recording and then start it again. So I had to let it keep running. Otherwise, everything that we did up till now would be lost, and I don't want that to happen. Okay, so before, just to remind you of what we spoke of, all of the obtuse angles are equal to each other. So 1, 3, 5, and 7, they're all equal to each other. All of the acute angles, 2, 4, 6, and 8, they are also equal to each other. And a single acute with a single obtuse, like for instance, 1 and 2, 2 and 3, 3 and 6, 3 and 8, they're supplementary and 180 degrees. So if angle 1 is 130, then that tells you that 3 is 130, 5 is 130, and 7 is 130. Now, if 1 is 130, together 1 and 4 have to add up to 180 degrees because they make a half a circle. Half of 180 is 360, half of 360 is 180, and they make a straight line between them. They're adjacent, so they have to add up to 180. They're supplementary. So 4 is 50, which means 2, 6, and 8 are also 50. Okay. Well, let me go back a sec. So I said, how did I get those answers? There are 3 ways, and let's review those now. The first way is we can do drag and drop. We said 30 and 150 because they together are supplementary. 50 and 50 because they're vertical. 130 and 130 because they're vertical. I can do drag and drop, which means I take the top set of angles, drag it, drop it on top of the bottom set, and likewise, the 30s and the 30s and the 50s fall into place. 30, 50, 130, 50. We can see our nice little animations here. By drag and drop, they land on top. The ones that land on top of each other are called corresponding angles, and you get equal angles that are created. Now, the next technique we mentioned before was if they're all acute, they're equal. If they're all obtuse, they're equal. 1 acute, 1 obtuse, add up to 180. If the measure of angle 1 is 70, find all the other angle measures. Go ahead. Okay, so if 1 is 70, so is 3. 2 has to be 110 because together they add up to 180 degrees. That means 4 is 110. Now, 7 is acute, so that's 70 degrees. Now, remember what acute means. Acute means that the measure is less than 90 degrees. 90 degrees is perfectly vertical, like vertical and horizontal, or they make a right angle. If you look at this green line here to here, that's a 90-degree angle. Angle 3 is smaller than that. Angle 3 looks like this. It goes to here and then down here. That would be acute. 7 is acute, 5 is acute, 6 and 8 are obtuse. All the acutes equal 70, all the obtuses equal 110. The acutes equal each other, the obtuses equal each other. 1 acute and 1 obtuse add up to 180. Okay. And I'm wondering why. There we go. Okay. Next one, angle 2 is 55. Find the measure of all the other angles. Okay, so 2 is 55. All the acute angles are 55. Every single start angle is 55. Now, find all the obtuse angles. Well, all the obtuse angles are going to be 180 minus 55 because the 55 plus the missing angle has to add up to 180. So that's 125, which means all of the lightning bolt angles are 125, 1, 3, 5, and 7. All acute angles are equal. All obtuse angles are equal. 1 acute plus 1 obtuse is 180 degrees. That's the acute obtuse method. Now, For these numerical questions, you can do them any way that you like. You could also, if you remember, the third technique is to memorize things like alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, and consecutive interior angles are supplementary. Okay, if angle 1 is 117, find the measures of all the other angles. Now, I'm not nuts that you memorize terminology at this point. I'm really big on you seeing relationships at this point. Understanding why two angles that are next to each other, adjacent, add up to 180, because it's half a circle. Circle's 360, half of 360 is 180. To understand why all the acute angles are congruent to each other, why all the obtuses are congruent, and why one of each add up to 180. If you see that relationship, it'll develop into what we're going to be doing in our next lesson. So, angle 1 is 117. Immediately, that means 3 is 117, right? In fact, on this one, I'm even going to do it with drag and drop. So, 3 is 117. 2 is 63 because I got to do x plus 117 equals 180, or 180 minus 117 is 63. 4 is 63. And then I do drag and drop. I take the top set, it'll land on top. And that means 117, 63, 117, and 63, where I place them. What angle corresponds to angle 1? Well, that would be angle 5, because when you do drag and drop and they land on top, that's the corresponding angles. What angle corresponds to 2? That would be 6. What about 4? 8. And what angle corresponds to angle 7? That would be 3. Okay. I don't know why we're doing the same question again. Okay, those are all 115. These are all 65s. Practically the same question. Okay, let's try this one. Angle 2 is 73. Find all the missing angles. Okay, so if 2 is 73, that means 4 is 73. 1 is 107 because they're supplementary, and 3 is 107. Okay, 5 is going to be 107. 7 is going to be 107. Those are all of my obtuse angles. Here's all my acute ones. They are all 73. All right. So far, let's remind us of what we've talked about. You could think about drag and drop and they land on top, or you could think of that diagram as being made up of acute angles and obtuse angles. All the acute angles are equal. All the obtuse angles are equal. One acute angle plus one obtuse angle always adds up to 180 degrees. Okay. The third approach is proper mathematical jargon. Alternate interior angles of parallel lines are congruent. We spoke about that. That's angles like here and here. They are alternating which side of the transversal, and they're interior or in between those two parallel lines. Exterior angles are outside the parallel lines. Alternate exterior angles, likewise, are also congruent. Corresponding angles, that's when you do drag and drop, they land on top. Those are congruent. And consecutive interiors are supplementary. So you could also memorize the proper math jargon for that. Okay. Those two angles, alternate interior. What about those two angles? They're also alternate interior. What about the blue triangle and the blue triangle? What are they? They are alternate exterior, right? Because they alternate sides of the transversal, but they're in the exterior parts of the parallel lines. They're not in the interior. What about those two? Aha! These two are alternate exterior as well. Now, a little reminder of the interior angles. What about these two? That's what we mean when we are talking about option 4 here. They are consecutive because they're in a row, and they are interior angles because they're inside the parallel lines. So those two diamonds are consecutive interior angles. We know that they're supplementary and add up to 180. So far, math summary for technical terms. Interior, inside the parallel lines. Exterior, outside the parallel lines. Alternate, switch sides of the transversal. Corresponding, drag and drop, they land on top. And consecutive means in a row. They're never alternate. They stay on the same side. Now let's apply some algebra to our work. Take the same concepts, but what happens now? So in a problem like this, what you're going to have to do is ask yourself, are they congruent or are they supplementary? Those are the only relationships shared here. By the way, you know the triangle, the lines are parallel because of the red markings on each line showing triangles in the same direction, same number of triangles. So that would be parallel. So the question is, does 12x plus 3 plus 11x plus 9 equal 180, or does 12x plus 3 equal 11x plus 9? Figure that out and solve. Okay, so I'm looking at this diagram, and those are two acute angles. Acute angles are equal to each other. You could also do drag and drop. It would land on top. Their corresponding angles, they are equal to each other. So 12x plus 3 is going to equal 11x plus 9. Get my x's on one side, numbers on the other, because this is linear, not quadratic. That gives me x plus 3 is 9, subtracting the 3, x is 6. Okay, try this one. Now, two ways to look at this. The first is that these are consecutive interior angles and that they must add up to 180 degrees because that's what consecutive interior angles do. Or I could say one is acute and one is obtuse, so they have to add up to 180 degrees. Notice they are not alternate. They are on the same side of the transversal. Alternate would mean one would have to switch sides. Consecutive interior angles are supplementary. Now they're going to add up to, I've wanted to say this for a while, as Count von Count would say from Sesame Street, 180 degrees. So 2x plus 3x plus 20 is 180. Same side, same operation. 5x plus 20 is 180. Subtracting the 20, 5x is equal to 160. Dividing by 5, and x is 32. Okay? The happy recap. In a linear system of equations, this is review here. In a linear system of equations, if everything's lined up, the x's over x's, y's over y's, and so on, that means we're going to use the elimination technique. If they're not aligned, if I get x's over y's, and particularly the equal sign are not aligned, that is a signal that we're going substitution. In the quadratic linear system, we always substitute. Number 3, parallel lines cut by a transversal. Remember, all the acute angles are equal, all the obtuse angles are equal. One acute plus one obtuse is 180. And a great big X means the angles across from each other are vertical angles and they are equal. And the ones that are next to each other are supplementary. They make a straight line. So we have introduced our beginnings of geometry. For the next lesson, we're going to take our parallel line concepts and start bringing them into triangles and a couple other shapes as we progress. The ways to succeed in class. You hear my dog snoring here. Don't snore in class. Do all your homework when it's due. It's about 10% of your grade. As I'm making this video, we're into I believe, our second week of classes. I'm obviously ahead with the videos. This is the first time the course has ever been taught, so I need to get all the work done ahead of time. There are students, I teach 2 classes right now. I teach MTH 1200, your class, and MTH 1000. There are many students in the 1000 class who haven't even done a single homework yet. Now, they've had half the homeworks because it's a full semester. But that's the surest way to fail. Single most guaranteed way to fail. You want to make sure you get that work done. Always do the homework. Basically, if you don't do the homework, you're going to go down a grade level. If you would have had an A, you go down to a B. If you would have had a B, you go down to a C, and so on. But when you don't do the work, you don't learn the material as well either. So you go down like another grade level or more because you don't understand the material the way you should. So maybe you should be a B student, but when you don't do the work, the B turns into a possible F. And listen, I got to tell you, I care greatly about the students in my class, and I don't do things just to be hard on students for the sake of being hard on them, because I don't believe in that. But I also believe in teaching responsibility and a work ethic. And here's the deal. If you put yourself in a position to fail because you're lazy and you don't do your homework, then you have put yourself in a position to suffer. I didn't do it. I gave you the homework to make sure you would understand the material. And if you do it all, it's kind of like, not exactly like, but kind of like raising your grade a point level. So I'm rewarding you with a B going up to an A or a C going up to a B, pretty much. If you don't do your homework, then you get yourself punished. Okay. How you go about your business is absolutely critical. It is extremely important. It is the key to your success. It's not how smart you were born. It's how you go about your business. Pay attention to due dates. They're all over Moodle. Everything is on Moodle. Work together on projects. Take pride in your work. If you do that, if you get your work in on time, you work together on projects, collaborate. For this first project that's been going on way back when, it's not going on anymore, I actually had you guys send your work into me so that you would get an idea how you're doing before you final submitted it. And then last, every day is your day. Every day is a chance to realize your dream. You're either progressing towards your dream, if not. If you spend the day playing video games, doing no schoolwork, doing nothing to improve your position or your standing, then you're not getting closer to your dream, unless your dream is to play video games. You want to make sure that you're making progress, and the way you make progress is you do work every single day. Have an awesome day. Enjoy. Hasta la bye-bye.